Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In the past lecture or session, we were talking about eigenvalues and eigenvectors. In fact, we did one of the functions when we tried to raise a matrix to the fifth power. So quickly, I mentioned that I can take a square root of a function or the sign, or I raise it to a power and so on and so forth. So I will try to um, give like a couple of examples with a 2 by 2 matrix and then one for a 3 by 3. If I find that the session is too long, maybe I'll do the 2D or a 2 by 2 matrices now and then a 3 by 3 one next time. So I don't want to make it too long and boring for you. So the first example, so we can save time, I'm going to refer to the same matrix, 2, -1, -6, 1, and tell you, suppose this is the matrix we have, okay? So my matrix A is 2, -1, -6, 1. Find the square root of A. But yeah, remember we described A already. There is no reason to repeat the work. We describe it as that. So my A can be rewritten as, I'm going to take the 1/5 out again to simplify things. 1, 1, 3, -2. If you remember, these were the eigenvectors corresponding to the eigenvalues -1, 4, 0, 0, -1 and 4. So this goes with -1, and this vector goes with the 4. And then we multiply by the inverse, which is, I already took the 1/5, so it's 2, 1, 3, -1. That's matrix A. So now if I want to find the square root of A, all what I have to do is take 1/5, 1, 1, 3, -2, 2, 1, 3, -1, and then take the square root of the numbers inside. Notice here I have a -1, and we know that the square root of -1 is I, the square root of 4 is 2, 0, and 0, and that's it. Now it's a matter of just multiplying. So if I multiply the first two matrices, I will get I plus 0 is I, 0 plus 2 is 2, 3I and 0 is 3I, and 0 minus 4 is -4, times 2, 1, 3, -1 equals 1/5, times 2I plus 6, I minus 2, 6I minus 12, and 3I plus 4. That's it. Here is the square root. And you can find anything, cube root, fourth root, whatever. To check your answer, you can multiply this matrix by itself, right? You cannot do that with a calculator. You may do it with a computer. But if I multiply this matrix by itself, for example, 1/5 times 1/5 is 1/25. And then I'm going to see how we multiply this 2 by 2 matrix. And to make it easy for you, I'm going to multiply it by itself instead of doing it within the matrix. So it may be confusing to many. So to get the first element, I'm going to multiply these two. So 2I plus 6 squared. That's 4I squared plus 48. I'm sorry, 24. 24I plus 36. Notice I squared is -1. So this is 24I plus 32. Okay? And then we're going to add to it 6I squared, which we can simply say -6, plus 24, And then I have negative 12i minus 12i with negative 24i. They cancel each other, and you get 32 minus 6 is 26, and 26 plus 24 is 50. Notice that 50 divided by 25 will give you this too. Then you go to the second element, which I'm going to multiply these two and those two. Meaning, I'm going to multiply I minus 2 by the sum of these, just to save time. Do you see what I'm saying? Instead of saying 2i plus 6 times I minus 2, and then I minus 2 times 3i plus 4, I'm going to multiply those and get 5i plus 10, if I add those, and multiply it by I minus 2. So 5i squared is negative 5, negative 20, negative 10i plus 10i, they cancel each other, so you get negative 25. Again, negative 25 over 25 is that negative 1. Then I'm going to multiply these two and those two. So when I multiply these two, I get 6i squared plus 24. Oh, I'm sorry. Yeah, I was getting this, right? So we are going to get, why did I do that? Why did I multiply? I already did this. Okay, so I get 12i squared, which is negative 12, minus 72. And then I'm going to get negative 24i and positive 36i. And then when I multiply these two together, I get 3i squared, meaning negative 9, and positive 16. And then 12i and 12i is 24i. What did I do wrong? No. I'm multiplying the wrong thing. Negative 36 plus 24 is negative 12i. Negative 12i and negative 24i is negative 36i plus 36i. They cancel. They always cancel, right? But what did we get when we multiply here? You got the negative 12, the negative 72, and then you got the negative 18 and negative 48. Right? Am I doing something wrong? No, I think that's correct. I keep multiplying the wrong thing. I'm sorry. So negative, so here you get 2 and 2, 4 and 8, 12 and 8, 20. Carry over the 2, 3, 10, 11, 15, negative 150. Negative 150 over 25 is negative 6. And finally, I'm going to multiply. Yeah, that's what I was trying to do by error. I was trying to get the last one instead. So I get 6i squared, that's negative 6, plus 24. Yeah, you see, negative 6 plus 24. I was doing this before that. I don't know why. Okay, and then you have negative 12i and negative 12i with negative 24i. And then when you multiply these two together, you get 9i squared, which is negative 9, plus 16, and then 12i and 12i, which is 24i, they cancel again. 24 minus 6 is 18, minus 9 is 9, plus 16 is 25. When you divide it by 25, you get 1. So that's you get 1, 2, negative 1, negative 6, and 1. So it checked. You don't need to do that if you are, sure you did it correctly, the multiplication. So we know that this is the correct answer. Okay. So now I said I'm going to give you another example. And this one, suppose now we want to do the following. I have a matrix, and this matrix, which one did we take here? This was 2, 1, 2, negative 1. No, I need something else. So do I have something here? There is one that says, it's similar to this. It starts with 2, -1, but then I have -4 and 2. Find a to the I. So I want to raise it to a power, but this power is imaginary. If you don't want to do the the long way and find the eigenvalues, you can see that the trace is 4 and the determinant is 4 minus 4 is 0. So two numbers that add up to 4 and multiply to 0, they must be 4 and 0, right? So we already know the two. And you say 0 is an eigenvalue? Yes, because if you multiply that by a matrix, we'll see first, and you should get 0, meaning no direction. It's a point. The vector vanishes, which we can say, yeah, we shrank it until it became 0. So it's valid. But the way we are going to do it is to say 2 minus lambda, -1, -4, 2 minus lambda, and you equate that to 0. So you get lambda squared minus 4 lambda plus 4 minus 4 equals 0, right? So lambda times lambda minus 4 equals 0, lambda equals 0, or lambda equals 4, as we expected. That's easy. For lambda equals 0, the first eigenvalue, you will have, of course, when you subtract 0, you still get 2, -1, and -4, 2. Notice that if you multiply the top by -2, you get or if you divide the bottom by -2, you get the top. So these equations are dependent on each other. So if I say V1, V2 equals 0, 0, I get 2 V1 minus V2 equals 0, meaning V2 equals 2 V1. So I can write it as V1 times 1, 2, right? So 1, 2 is the eigenvector. Let's try and multiply this by 1, 2 and see what we get. You get 2 minus 2 is 0, -4 plus 4 is 0. Of course, that's what we expected because lambda was 0. Okay, for lambda equals 4, you get 2 minus 4 is -2, -1, and -4, and 2 minus 4 is -2. Again, the bottom is twice the top. So when you multiply that V1, V2, you get 0, 0, and that tells you -2 V1 minus V2 equals 0, meaning V2 equals -2 V1. So to save time, that would be 1 and -2. And again, if you multiply that by 1 and -2, you should get 4 times the matrix. So if I multiply it, I'm going to write it in blue. 2 plus 2 is 4, and -4 minus 4 is -8. This is basically 4 times 1, -2. So we know that we did that correctly. Now, how do we raise this to the ith power? This matrix can be written as V1, V2, which is 1, 2, 1, -2, times 0, 0, right? Because the lambda 1 was 0 and lambda 2 was 4. And then I get the inverse of that. This is -2 minus 2 is -4. So the way I'm going to do it is to switch these two and then divide by -4. So -2 by -4 is positive 1/2. And 1 over -4 is -1/4. As for the other two, you leave them as they are. You just change their sign, and divide by -4. So if I change their sign, they become negative, but when I divide by -4, they become positive. So I get a fourth and a half. And that would be to the I. Okay? But what is 4 to the I? 4 to the I can be written as, usually when you get something to the power of I, you write it like e to the natural log of 4 to the I. And the properties of natural log tells you if there is an I, you can bring it down as a multiplier. So this is e to the I natural log of 4. And when you do it like that, you know from Euler's uh, equation or from how to transform, uh, you know, any vector like that. Notice we know that e, we can write it as e to the I theta, which is cosine theta plus I sine theta. And then Euler, when you apply theta equals pi, you get e to the I pi equals cosine pi, which is -1, sine pi is 0, so you get e to the I pi equals -1 or e to the I pi plus 1 equals 0. You can see it in both forms. So this can be written as 1, 2, 1, -2 times 0, 0, 0 times, you can take the -4, you can take 4 out if you want, 1/4, and write this as 2, 1, 2, -1. It's easier. And here you can write cosine natural log of 4 plus I sine natural log of 4. Now, when we multiply the first two matrices, you get 0, 0, of course. And the second also would give you 0 and 0. When you multiply this, you get cos natural log of 4 plus I sine natural log of 4. And then the last one, you get 0, -2, so you get -2 cos natural log of 4 minus 2I sine natural log of 4. Everything multiplied by 2, 1, 2, -1 equals 1/4 times 0. And here you get 2 cos natural log of 4 plus 2I sine natural log of 4. And here you get 0, and you get negative cos natural log of 4 minus I sine natural log of 4. At the bottom, you get 0, and then 2 times that, so -4 cos natural log of 4 minus 4 sine natural log of 4. And here you get 0, and the negative would make that positive 2 cos natural log of 4 plus 2I sine natural log of 4. And that's basically how you raise a matrix, a 2 by 2 matrix, to a negative, to an imaginary power. Okay? Again, I think that's enough, because if I do a 3 by 3, it will take a long time, and it's almost now like 20 minutes. So that would take much longer. So I'm going to stop here. Assume this is a short session, and then soon enough, I'm going to start giving a third one on functions of eigenvalues or function of matrices for a 3 by 3 and take a 3 by 3 example. Okay. Thank you very much for your time and hope to see you soon.